Hello once again, and today we're going to talk about our final topic from our three-dimensional geometry unit, and it's about spheres. A sphere is essentially a ball, and I want to go over some of the vocabulary that we have here so that we can make sure that we're all talking about the same thing. And there it is. All right. So the definition here is, it says a sphere is a locus of points in space that are a fixed distance from a given point called the center of the sphere. So obviously that's the center of the sphere right there, okay? And so the sphere is all the points that are the same radius away from that center. And you'll notice we use the word radius the way we do in circles. So a great circle is the circle that divides the sphere into two hemispheres. Hemi meaning half. So we have two hemispheres, half spheres, that make up the whole sphere. The figure shows a hemisphere and a cylinder with the cone removed. So you can see what they're talking about here. This is the cone that's removed. And the cross-sectional area, meaning that if we cut a slice out of here and we cut a slice here, okay? We know by Cavalari's principle that those volumes will be the same. Those areas will be the same, and if we do it at all levels of the height, the volumes will be the same. And we're going to talk about that a little bit later. So, what we want to talk about here is the area of this hemisphere, okay? Or excuse me, the volume of the hemisphere, this whole thing right there, okay, is actually equal to the cylinder minus the cone. So once again, so here's the cylinder right here, and we're going to say that that hemisphere is equal to the cylinder minus the cone. And so we just have to come up with a few of the formulas here. Obviously the volume of the cylinder is this. That's the volume of the cylinder there, and that's the volume of the cone that we're subtracting out. Okay? Finally, we do that and we get the volume of the hemisphere is 2/3 pi r squared h. Okay, and we can go rewrite it. We can say here, you can see r, excuse me. We can say here on this step, r squared times r is actually equal to r cubed, which then helps us with that step. So finally, we know a hemisphere, there are two hemispheres, so what we need to do is we need to double that formula. And by doubling it, we get the volume of the entire sphere, 4/3 pi r cubed. And that's where the formula comes from. Make sure you put it into your notes this way. The volume of a sphere, indeed, is 4/3 pi r cubed. If you didn't fully get that explanation of where this formula comes from, be glad to stop by during my office hours and I'll give you one-on-one on that. All right, let's go use the formula then. So find the volume, let's see here. Find the volume of the sphere, give your answer in terms of pi. All right, so let's take a look. They've given us a diameter, and they've told us the diameter is 24 inches. So that means the radius is half of that, 12 inches. So the way I draw these on my paper, if you want to learn, is you draw a circle first to draw a sphere, and then you draw a little curvy part there and a dotted curvy part like that. And that's how you draw a sphere. And then finally, you label that 12 inches. All right, like any of the formulas, Mr. Haley always encourages you to write down the very generic formula and then substitute in, replacing any variables with parentheses. And in this case, our radius, as we figured out before, was 12 inches. Now be really careful here. Do not be tempted to cancel this 3 with this 12 because you have to go do the exponents first. So let's just go ahead and do that over here. We've got 12 to the power 3, use the caret, 3, enter, times 4 divided by 3. All right, so we get 2,000 and 4 pi. Now it asks us to leave our answer in terms of pi. Of course, we can go find the approximate answer by multiplying out by pi, and we get the volume is 7,238 point, and we'll round off to the nearest tenth. And let's put inches cubed on all of these here. Cubed. So there's my approximate answer, and my answer left, the exact answer, in terms of pi. So you can see it's fairly straightforward to finding the volume. We can work backwards, where they give us the answer, and they give us the total volume here in this next problem. They give us the volume, and we come find the radius. So let's go ahead, start with the general formula, and let's substitute in what we know. In this case, we know the volume is 10,000, and we want to go solve for R. All right, so that turns into 30,000 4 pi r cubed, and we do 30,000 divided by 4, which I'm sure it goes in beautifully, and we get 7,500 pi r cubed. Still want to get rid of this pi right here. We want the r cubed by itself, so we get this. And then, to solve for r, we're going to have to take the cube root of both sides. 7,500 pi cube root of r cubed. And obviously, the cube root of r cubed is just r. And to do this on the calculator, take the cube root, we're going to type in 7,500, one too many, divided by pi, and then we're going to put it to the power 1/3. And that's the same as the cube root. And there we have it. So that gives us that our radius is 13.3, and our units were feet. I'm going to go ahead and copy that, put this in here so you can see exactly what we did. The key thing is to do the cube root, you've got to do 1/3 to the power 1/3. All right, finally, we're talking about the surface area of a sphere, and it's equal to 4 pi r squared. So it's you can actually, there's a great hands-on demonstration of peeling an orange, and then you figure out how many circles you can make out of it with that radius, and indeed it turns out to be 4. So that's another formula. That's another formula that you need to memorize there. Surface area, meaning if we were going to paint the outside area of the sphere, how much paint would we need? How many square feet or how many square centimeters? So let's go ahead and do this problem now. Find the surface area of a sphere with a diameter 76. Give your answers in terms of pi. All right, immediately I always convert everything into radii. So 76 divided by 2, how about 38 centimeters? And then we're going to plug this in. The surface area is 4 pi r squared, 4 pi, and our radius in this case is 38 squared. Now, once again, you've got to do the exponent first. You can't multiply the 4 times 38 until you've squared that 38. So let's go over here and do 38 squared, entered, times 4. Now we get 5,776. All right, and then we have to bring down the pi. So that's the answer in terms of pi, and we're talking surface area, so it's going to be centimeters squared. And as always, I always like to get a nice approximate answer, so let's multiply that times pi. And there she is. That works out well. So 18,145.8 centimeters squared. So that's how you find the surface area of a sphere. So let's just keep this in mind here. Here we were finding the volume of the sphere, how much when we're filling it up like with a liquid. And here, the surface area, we're talking about painting the outside. All right, so next we have this composite problem. Find the surface area and the volume of the composite figure. The volume will be easier. We will go do that first. The volume is going to be, now this is not a whole sphere, it's a hemisphere. So it's going to be half. Oh, you know what we need to do first is to draw pictures. So it's going to be do. That's the top. And then we have the cylinder. Okay? And they both have the same radius. Be careful, it's not 12. What is it? It's 6. So we go mark that in there, mark that in there. The height here is 9. And these are all inches. They haven't confused the units on us, which is great. So now we're going to go write the formulas. A hemisphere is half the volume of a sphere. And a cylinder is simply area of the base times the height. In this case, the area of the base is pi r squared times the height there. So let's go ahead and substitute in, not simplifying anything. In this case, our radius is 6. Did I lose? There you go. Pi r, oh, excuse me, pi, and then this is a 6 squared, and the height is 9. All right, so let's go ahead now. And we can simplify these two things here, and we get 4 over 6 pi, and 6 cubed is 36 times 6 is 216. And over here we have 36 times 9, don't know what that is, times 9, and that's 324 pi. And finally here, 4 times 216 divided by 6, 144. And don't forget these are both pi's. Finally we get 144 plus 324, and we get 468 pi for the volume. So 140, that's good. Just checking that I'm on. And we can, and it says to leave in terms of pi. This time we will, just for time's sake. And this is cube. For the surface area, you can see what we have is half the surface area of a, the top part of half a sphere. So this total surface area is going to be equal to hemisphere plus. Now with the cylinder, we've got a circle on the bottom and we've got the outside edge. So we've got a circle on the bottom and we've got the outside edge, which rolls up into a rectangle. So let's go ahead here and put some dimensions on it. I'm going to change colors. Here the radius again is 6. Here the radius is 6. And here the height is 9. And this dimension here is actually, as we've talked before, in a cylinder, it's the circumference. So that's 2 pi 6. 2 pi r. All right, let's go ahead and write the formulas down and be done with this problem. So here we have half the surface area, which is 4 pi r squared, plus pi r squared, plus base times height. I'm going to cheat a little bit this direction. 4 pi, and our radius was 6, plus pi 6 squared, plus our base is 2 pi r, and the height was 9. Sorry, I'm kind of running out of room there. All right, we can simplify the 1/2 of 4 is 2 pi 36 plus 36 pi plus 2 times 6 is 12 times 9 is 108 pi. So let's go ahead and add all these up. So let's see here. 2 times 36 is 72 plus 36 plus 108. And that's the pi. So the correct answer here is 216